All right, so the infinite sum formula, it can only be used if it's a geometric series, okay, or sequence. So it doesn't work if it's an arithmetic sequence, only geometric. The formula is really simple. It's just a1 divided by 1 minus r. Now, r has to be a fraction, and it should be the absolute value here. So go ahead and put absolute value bars. It's the absolute value of r has to be between 0 and 1. So it has to be a fraction. It can be positive or it can be negative, but it has to be something between 0 and 1. It can't be 0 and it can't be 1 though. All right. So positive a half is okay. Negative a half is okay. All right, because the absolute value of negative a half is positive a half, and that's between 0 and 1. Right? So it could be positive or negative. Just has to be between 0 and 1 though, if you take the absolute value of it. If r is, let's say, 5, you're multiplying by 5, then it doesn't work. All right? There's no sum if r is outside the boundary between 0 and 1. All right, so let's go ahead and apply this formula to these problems. So these are all geometric here. And so we're going to find the sum. And so we're taking this this sequence here, this first one, 16, 8, 4, 2, and so on forever. Okay, so there's billions and billions of numbers in this sequence, and we're adding them all up, and we want to know what the sum is if we add all those numbers up. All right, so S infinity equals, so what's the first term? 16, good, divided by 1 minus r, and so what's the r value? No, 1/2. Okay. Now we just simplify it. Okay. So you have calculators. That's why you use calculators. 1 minus a half. It's a half. All right, and then do 16 divided by a half. Your calculator, if you use the calculator, should say 32. $16 divided by a half is the same as 16 times the reciprocal of a half. So 16 times 2. All right, so again, if we take 16 plus 8 plus 4 plus 2 plus the next number 1 plus the next number a half plus the next number and the next number all the way out, billions and billions of places, okay, the sum, if we add all those numbers up, is extremely close to 32. Okay, it's not going to be exactly 32. It's a rounded answer. It's actually like 31.999999999 forever. So we say 32. Okay. All right, B. Let's do the same thing. All right, so S infinity equals A1 is 81 divided by 1 minus R. And so what's R in this one? 1/3, good. 1/3. All right, 1 minus a third is 2/3. All right, so then we use our calculator. Glasses. 81 divided by 2/3. That's 121.5. You can use the fraction a half. You can use the decimal, 0.5. Remember, decimals are okay as long as decimal stops. If the decimal goes across your screen, doesn't ever stop, then give the fraction answer, unless in the directions it says you can round it. Fractions are always better. Exact answers are always better. Okay, unless in the directions it says round it. All right, C. All right. So A1 is 1 divided by 1 minus R. And so what's R? 4. All right. So you'll see that this answer isn't going to make sense. Because 1 minus 4 is -3, and 1 divided by -3 is -1/3. Now, if we were to take our sum there, or the sequence, and take 1 plus 4 plus 16 plus 64 and keep it going forever, we can see that it doesn't make sense that the answer would be -1/3. And the reason why is because r is outside the boundary of 0 to 1. It has to be a fraction between 0 and 1. And so that doesn't make sense, so we just write no sum. It goes on forever. It's infinity. All right, D. So this one we do have a sum. Right, so 40 divided by 1 minus r. What's r in this one? 1/4. Good. 1 minus 1/4 is 3/4. 40 divided by 3/4. So this one, it depends on your calculator setting, but if you get the decimal, it's going to be 53.33333 forever. All right, so because it doesn't tell us around it, we want to give the fraction answer. And so it'd be 53 1/3. Or you can give that's the mixed fraction. If you want the improper, it's fine also. 160/3. So either answer is fine. All right, let's see, E. So now they give us a formula. It's explicit for geometric. All right, so what's the A1 term? So give us the formula. What is it? 8, right. And then what's R? 0.2, right. Okay. So if you look at your formula sheet, the explicit rule for geometric, it's already in the form A1 times R to the n minus 1. So A1 is 8, R is 0.2. All right, so 1 minus 0.2 is 0.8. So that's going to be 10. Then go ahead and try F. Find the sum. All right, so you should get 16. All right, so go ahead and turn it over. All right, so now we're going to look at this new symbol. This is called the sigma notation, sigma symbol. This is the Greek letter. This symbol right here is used a lot in higher levels. So as you get into pre-calc, if you take calculus and so on, they use the symbol. And so it's the symbol for the sum of a series. So instead of having to list out every single number of the sequence or the series, and then telling you to add them all up, what they do is they use the symbol instead. Now there's 3 parts to this symbol. There's this bottom part where it says n equals 1. So it's always going to be a variable equals a number. Now for you guys, it's always going to start with 1. But if you take pre-calc and higher, it doesn't have to start with 1. They could start at 0. They could start it at 2 or 3 or 4. So that's all it's saying is start with that term number in the sequence to add them up. So if you're starting with 1, they're just saying the first number of the sequence is where they want you to start. If they started with 2, they're saying start with the second term of the sequence and add up your numbers. That's all that is. All right. And then the top number is going to tell us where to stop, which term number to stop at. So in this case, there's 4 numbers. Okay, so we're stopping at the fourth term. And then there's the AN rule, the explicit rule that's off to the side. It's going to be either arithmetic or it's going to be geometric. Right? That's our AN rule that's off to the side. So those are your 3 parts. And so if we take 5 plus 8 plus 11 and 14, that sequence, we can see it's arithmetic, adding 3 each time, right? And so if we were to use the explicit rule and write it out, it is 3n plus 2. So taking 5 plus 8 plus 11 plus 14, instead of writing that out, we're going to write it this way instead, using the symbol. All right, so let's go ahead and practice doing that for number 1. So they give us this series of numbers, and they want us to write it in summation notation. All right, so the first thing we're going to do is draw the symbol for the sum. You can impress your friends. They're going to go, ooh, that looks so cool. I don't understand it, but you will. All right, so here's our sigma symbol. On the bottom, we're going to always start with n equals 1. The top, we're going to count up how many terms we have that we're adding up. So there's 1, 2, 3, 4, 5. So 5 goes on top. All right, now off to the side, we're going to write our AN rule. So we have to figure out, is this arithmetic or is it geometric? It's geometric, and so we can see that we're multiplying by 2. So we take our explicit formula on our sheet for geometric, that's the A1 times R to the n minus 1, and plug the A1 and R in to the formula, and then we have it. We're done. You don't write AN equals, so don't put the equal sign. You're just putting everything that's on the right side. Okay, so it's the first term 3 times R, which is 2, raised to the n minus 1. So all of this is the same thing as writing this out. Exactly the same thing. All right, so let's go ahead and do B. Again, we're going to use our sigma symbol. All right, n equals 1 on the bottom. Count up how many terms you have, so you have 4. All right, so is this arithmetic or is this geometric? It's arithmetic because we're subtracting 5, has a d value. All right, so you're going to go off to the side and write your explicit rule. Okay, use your arithmetic rule formula. And so I'll just do it off to the side here. So it says take the first term, A1, 18, plus n minus 1 times d, and d is negative 5. Then we distribute the d value in, and then collect like terms. So negative 5n plus 23. Or 23 minus 5n. The order doesn't matter. All right, and then C, sigma symbol, n equals 1. Now, because of the dot, dot, dot after it, that means this is an infinite series. So we're going to put the infinity sign on top. Because there is no last term. There aren't a total number of terms, so because it goes on forever. All right, so now we're going to write the AN rule. This is geometric. So it's the first term is 100 times R, which is a half, raised to the n minus 1. All right, so now we're going to go ahead and find the sum, and they give us it in sigma notation. All right, so for number 2a, we're going to look at the rule off to the side and find out, is this arithmetic or is it geometric? Right, it's arithmetic. We know it can't be geometric because it doesn't have the n minus 1 exponent. That's what gives it away. It's got to have an n minus 1 exponent. And we know it's arithmetic because it's in the form of y equals mx plus b, the mx plus b part. All right, so we know it's arithmetic, which means there's a d value and not an r value. So what's the d value? -2. Remember, the d value is the same as the slope. Since this is in the form of y equals mx plus b, and the m is -2 because that's the number in front of the variable, the d value is -2 also. All right, so now we got to find the sum. And so we're using the SN formula for arithmetic. So you go to your formula sheet, go to the arithmetic SN formula. That's the one you're using now. And we just plug in the 3 numbers into that formula and then use the calculator and let it calculate it. All right. So this top number, 20, that tells us how many terms there are. So we're looking for S sub 20. I'll just do it right here. So the formula says n divided by 2. So it's going to be 20 divided by 2 times A1. Now, to get the A1 term, you're just plugging 1 in for n, which is the bottom number. You plug it in for n into the rule and simplify it. That'll give you your first term. So -2 times 1 plus 1. So it's going to be -1. And then plus. Now we have to find a sub 20. So you take 20 and plug it in for n. So you put the bottom number in for n to get the first term, take the top number, plug it in for n to get the last term.
How did you get the first?
I put the bottom number 1 in for n. So -2 times 1 plus 1. So now -2 times 20 is -40 plus 1 is -39. And now I just simplify this term. So that's 10 times -40. So the sum will be -4. All right, so let's do B. Is this arithmetic or geometric? It's arithmetic again. What's D? 5, good. So we'll look at the top number in our problem, 30. So we're looking for S sub 30. So 30 over 2 times A1. So what's the A1 term? 5, because you're plugging 1 in for n. Plus A30 is going to be what? 150. Plug 30 in for n. Now you just simplify it. 15 times 155. So 2325. And so that's the sum of the first 30 terms. All right, C. Is this arithmetic or geometric? This one's geometric, which means there's an R value. What is it? 2. And since our top number is 10, we're looking for S sub 10. But now we have to use the geometric formula, not the arithmetic. All right, so make sure you use the finite one, not the infinite one, because there's two SN formulas, okay, for geometric. So we're using the finite. So S of 10 equals the first term, which is 6, times 1 minus r, which was 2, raised to the 10th power over 1 minus 2. 1 minus 2 is negative 1. Throw all this in the calculator. So 6138. All right, and last one. Is this arithmetic or geometric? This one's geometric. What's the r value? 2/3. Look at the top. This is an infinite series. So we're looking for S infinity. So the formula A1, which is 3, divided by 1 minus r, which is 2/3. 1 minus 2/3 is 1/3. 3 divided by 1/3